Alright, so hello and welcome. Here we are, another question. Trying to get it going here. Take a moment to make sure the audio is working. Is my audio okay? I think so, yeah. I think the mic is, it's got a lot of gain on it. Hello, hello. Take a moment to make sure. Yep, good. Alright. This is going to be, oh, actually, yeah. Excuse me, oh, it's a lot of drop frames. Oof. Remove subfolders from the file system. No, problem number 1233. Yeah, 1233. Okay. Given a list of folders, return the folders after removing all subfolders in those folders. You may return the answer in any order. If a folder of I is located within another folder of J, let's call the subfolder of it. The format of a path is one or more concatenated strings. I think I need to use a toothpick before I begin. Format of a path is one or more concatenated strings of the form / followed by one or more lowercase English letters. For example, LeetCode and LeetCode problems are valid paths while an empty string and / are not. Okay, so that's the format. So folder -a -b -c -d -c -c -d -e -c -f a c d c f. So remove the subfolders. Okay. Folders A, B is a subfolder of A, and CD is inside of folder CD in our file system. Okay. Not sure exactly how I want to do this. This is an interesting question though. 40,000 folders. Each folder is of most size 100. The lowercase letters and a /. We start with a unique character /. Each folder name is unique. Relatively low submission rate, high acceptance rate. Okay. I don't think this is too hard. I don't know the answer offhand though. I think I would need to, I think there are possibly a lot of ways to do this. Probably the easiest way to do this would use like something similar to a try, where I create basically using the name of the folder. I create like a tree structure type of thing, and the idea would be I can add, you know, a new branch to that tree as I go. I'm trying to think how I can do this. Because I don't necessarily know the order I'm going to see these things. I could see A, B before I see A. In which case, what I'd want to do is I'd want to remove A, B, and just keep A. Thinking of a way to do this. I think I've got to use hash sets because the strings themselves are unique strings. Specify the name of a folder. I want to break up each string into a sequence of hashes, a sequence of strings, and I want a hash set, a hash map of strings. And each string is another hash map. I can have just one hash map of strings to strings. So A to B. Always followed by one or more. Okay. Yeah. Could just have that empty string if it's a root directory. They said the folder names are unique. Okay. Maybe it should be an array, a vector of substrings, or it could be a multi-map. Maybe just a vector of children is fine. Child strings. Unordered map of strings and child strings. And what I would do is I would add, so I would say ABC, and I would add A with a child B, then I would add B with a child C, and then I would add C with an empty string. No, wouldn't add C with an empty string. And then when I added A, I would look up A, and I would notice that it's children, and I would delete the children. All the children. I'm trying to do this in one pass. I think I can do this in one pass, I'm not seeing it. Also, the parsing routine, I would also need to figure that one out, which I don't think is that hard to do. You can use a string stream, I think. iString stream. How am I doing on time? I feel like I've been at this for a little bit now. Yeah, 10 minutes already. Hmm. Sorry, my mind is wandering elsewhere. The problem with doing it the way that I just described, yeah, I think I need to use something like a struct. Problem with doing it the way that I described is that I won't be able to tell that something like BC is not actually its own directory, its own folder. I don't know the parents of B, basically. I don't know that B has parents. Yeah, that's the problem. So, okay, we'll just use a struct. That's something similar to a try. Just say folder, vector of folder children, and just have a name. Excuse me. And then we'll just have a vector of folders, or an unordered set of strings. Forest of folders. And I think this should also be an unordered map. And the reason I think that is because I think I want to perform lookups efficiently. So the way this is going to work okay. I want to parse the string. And I want I get each folder name. I'll take a pointer. I'm going to say if current find token, right? If I can find okay. Excuse me. I think I'm doing this wrong. I think I just need this to be a folder. Yeah, something like this. I think I'm not doing this correctly. As far as I don't think I'm doing this correctly as far as like how I would normally set up a try. Don't actually need a name. Excuse me. Okay. Okay. I don't know what to call that. Something like this. That's confusing. Huh. something along these lines. Something like this. And just perform a level order traversal. Just say I don't know how many exactly I should reserve, but we'll assume it's about half. I could just reserve n. That's fine. That works too. Okay. Well, the level is not empty. Say I think I can do it this way. Okay. I'll just call it F. It's level dot front. Level dot pop. And I'm gonna say it's kind of a mistake, huh? I think I maybe need a pair strings and folders. Maybe a DFS is what I want. I end up using a lot of memory if I do it this way. I don't think it's good. No, it's I think it's okay. I'm trying to think about this here. The problem I'm running into is when I recreate the strings and concatenate the names, at each step I've got to copy a new string for each child, potentially. And sorry, I'm kind of a little tired here. I'm not tired. I'm just moving very slowly. Oh, that's a lot of drop frames. Jeez, what is going on? 26 minutes in. Yikes. Trying to think here. I think it's okay. It's just I have to copy every string a second. What I'm concerned about is like recopying multiple times the same string. I think it's okay. It's confusing, but I think it's okay. I think it's all right. I'm not sure how it affects the runtime. Okay. All right. Anyway, so this is kind of an unusual way of doing things. Okay. Okay. So for each child, I don't know what to call this. Key value pair. Excuse me. And the children. I'm gonna say next level push. It's gonna be p dot first plus kv dot first and kv dot second. Yeah. If so, if it's complete, though, if p dot second, which should be a pointer, it's complete, then I continue. And in fact, I push this into the result. Yeah. Something like this is what I'm after. Not sure what I get if I do this. This is kind of complicated. This is like way more complicated than it should be, I think. A lot of drop frames too. Shouldn't be a compiler error. Should be an unordered map for strings. Why is there an issue there? Definition's not complete until the closing. Oh, it's just a note. Okay. What? What's the issue? Excuse me. What is going on? Oh. Okay. Excuse me. Oh, I see the problem. That's annoying. It's confusing, but I see the issue. Oh, yeah. Iterator boolean. So we should get first. Yeah. Okay. Something like this. Yeah, so these are folders, not pointers to folders. I'm just putting the folders directly in there, in the data structure. Not putting it on the heap. Or not, yeah, not putting that in the heap. No matching member function for call to push. Okay. Something like this. What is a pointer? So the value is the pointer. Yeah, the value is the folder. It's a folder pointer. No. Oh my goodness. Such a pain in the neck. Oh, no matching member function. Why? Why? Maybe that's why. Just need to make the pair. That's not the issue. This is a string. KB second. He has second children. Oh. Second is a folder. KB second is a folder. What is going on, man? Why? What? Right, this is definitely. What is going on? Why am I struggling so much here? Oh. I see. Running into some const expression issues. Am I going to modify? So these should be const folder pointers, because I'm not going to modify these, right? Is that true? I think that's true. Yeah, I'm not going to modify the. I'm not going to modify the tree at all here. Okay. That's kind of subtle. Easy mistake to make. Wrong answer. This also is going to be kind of slow, the way that I programmed this. Okay. Interesting. Seems to work the way that I've programmed this. This should also be probably something like this. There we go. Now, how come I can't do the same thing with an unordered map? This is a little bit strange to me also. This is taking me a really long time. Probably should have been able to do this in like a few minutes. Second member. Field has incomplete type folder. Oh. Huh. Oh. But this map works. What? What is going on? That's hilarious. A bug is failure to adhere to a requirement, and there are no requirements, so it cannot be a bug. Interesting. This is a pretty subtle thing. I've said before it's valuable to read the standard. This is the kind of thing that would be good to read the standard for. Okay. How do I complete the type in this scenario? Huh. I don't know if I can. Hmm. Hmm. Um, can you have a complete type that references itself? Hmm. Huh. Um, well, shoot. ODR means it's one definition. Took me a very long time to understand what that meant. What that's supposed to mean. Also, am I still dropping frames? No. Gee. Well, how am I supposed to do this now? How am I supposed to do this? No. I mean, I could use a map. Apparently a map works. Like, why does this compile a GC? Why is this? Self-referential class. CPP. How can you, what? Excuse me. How? What? Oh my goodness. This is. This is like. Oh, you gotta be kidding me. You know, I don't know what to say here. What to do about this. No. You've got to be kidding me. I can't do this? Are you kidding? What? No. 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 Oh. Uh, what does it mean to be ODR used? Oh. So informally, formally. Okay. It's a lot of reading to do. I don't think I have to read all that. Um, wait, what does this do? What? What? I aliases. That's so confusing. Pretty sure I've used typedef before, typedef before, and I know what it does. But oh, these are ill. I was gonna say, oh wait, oh, these are ill-formed. Okay, doesn't make sense to me. Okay, that's why I was so confused. Basically, make them all synonyms. Okay, yeah, all right. I was like, what is going on? What does this do again? But this is kind of weird. Doesn't this make... Um... Does this make unca equal the same as an int array? Okay. Oh man. Can I do this? This is so disappointing. This. Can I, this is like, I'm shocked, man. Shocked. Wow. I don't, okay. Oh wow, whoa. It's a lot of drop frames. How do I do this? As an incomplete type. But can I make, but I can make it a pointer. What? What? What is going on? Pointer to incomplete type. Am I crazy? Am I crazy? What? It's one of those things where I feel like I need to read the standard. What? How are pointers to incomplete types legal? How does the compiler know how big an object of type incomplete is? Since it can apparently figure out the size, why are regular object of incomplete size types illegal? The reason that pointers to incomplete types are illegal is precisely because the compiler doesn't need to know their size. The reason that you cannot declare an object of incomplete type is, as you mentioned, because the compiler doesn't know how large the object is and therefore can't allocate space for it. When declaring a pointer to an incomplete type, though, the size is known because typically all pointers on a machine have the same size. Moreover, you don't need to know how large the object is when declaring a pointer to an object of incomplete type. However, if you try using an object of incomplete type, such as by following that pointer or trying to instantiate an object of that type, then the compiler will give you an error. Short, the pointer is legal because it can be created without the compiler knowing the size of what's being pointed at. If you actually need to know the size or layout of that object by using the pointer, though, the compiler will need to have more information about the type. What? What is going on? No, I don't want to put everything on the heap. No. No. Well, that's awkward. Gee. Huh. Well. No. I wanted to try to keep this memory somewhat contiguous. I think I have to create a new. Can I create a unique pointer? Oh. um. Oh. Yeah. Oh. Well, this is confusing. Um. Hmm. This is so much more confusing. Oh boy. gee. Wow. I definitely can't do this, can I? Because this is incomplete too. Oh, this is so confusing. It's crazy. As my friend would say. It's crazy. Yeah, this is really p dot second is a pointer, yeah. Does this work? Does this even, I don't know. This is so confusing now. No. Oh, so it got through this part. Okay, this worked. I was able to make a unique pointer. All right. At least that's better than the than a freaking. At least it's better than the just using a raw pointer. It's like really not what I want to do. But now this is p dot second. Yeah, it's that. What changes now? Push. I think this just doesn't have. This is I need a dot get. That's what I need. Wow. Oh, okay. Okay. Sure. This is like, are you kidding me? What? What? This is very funny. Big sigh. Just a big sigh. Shared pointers, unique pointers, incomplete types. Isn't C++ fun? Isn't C++ fun? Do I just go for it now? I'm afraid to go for it. I think if I go for it, I'm gonna get bopped. I'm gonna get bonked. Why don't I go for it? Why don't I go for it? See how it goes. Might be a mistake in there somewhere. Oh, of course. I mean, sure. What even happened? To be, oh, okay, heap use after free. Alright, of course. Really? What? 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 No. How did that happen? No. Well, that's awkward. I mean, shoot. Really? Of course. It's one of the things I was unsure about. One of the things I was unsure about if I was gonna mix unique pointer, shared smart pointers with data structures, what they would end up looking like. Of course. Of course, of course, of course. Okay. Just gonna say a new folder. Okay. Just never free the memory. This is something, huh? I don't know what I did before to make a mistake. I did something that wasn't quite right. I don't know, man. Still a heap use after free. Oh, okay. What? I'm not even freeing anything. I don't understand. Huh. Ah. What is happening? Why? Oh. So much easier if I was just using the map. Okay. Let's just try to use a regular map and see what happens. I get the same error. Okay. Let's do oh boy. If I'm just allowed to do it this way. Something like this. This is it's pretty brutal to say. This is definitely rough. It's definitely rough. Oh boy. Okay. Why is this happening? Why is this happening? What do you mean there's a heap use after free? Oh no, wait. No. Is it because of this? Could be because of this, actually. I didn't think about that. Could just be that. Small chance that's the problem. That would suck. You know, I wondered about that before. Wondered about that. Oh. And now every path has to pop. Oh, you gotta be kidding me. Oh my goodness. No. So yeah, what happened is And I thought about this with other questions, other problems, where if I pop before I access the elements, would I run into problems? And the answer is depends. Usually when the only thing I'm dealing with are integers, doesn't matter when you pop if you set your variables equal to those integers. I shouldn't say that. I don't know. Something weird's going on where I think the issue is something like the following. Normally, the object that you're operating on, if you take a reference to it, right, it's not going to get deallocated, typically. If, let's say you have a queue, and you take a reference to the front of the queue, and then you pop the queue, right? The thing that you're referencing, that you've referenced to, now is no longer in the queue, but doesn't necessarily get deallocated immediately, I guess. Something like that. I don't really know. I think some of the code I've been writing in the past is not correct. Because I'm running into this problem now and I don't really know why. And, whoops. Well, gotta learn somehow, right? This is why you practice. Yeah, I thought that was weird. When you reference something and then pop it from the queue. Gee. It can get deallocated, and then you're trying to use it after it got deallocated. What? Like what? What is happening? What is going on? What do you mean? What do you mean? But why does that? Okay. So I understand why it doesn't work in this scenario, because I have an object as part of the pair, and excuse me, I have an object as part of the pair, and when I pop the pair, the object might disappear. Is that what it is? It's really confusing. What is happening? Why is this causing issues in the first place? That is so confusing. What is going on? I'm struggling here. I have so many questions. I have so many questions. Okay. So, oh boy. Excuse me. So there was a point where I wasn't using smart pointers, and I was just allocating. I wasn't even deallocating. I was just allocating straight to the heap. And for some reason, something was getting deallocated. I think the issue is that I was taking references to the front of the queue. And when I popped that pair off of the front of the queue, I think basically that became like a dangling reference. And I think that memory got deallocated. And sometimes it doesn't get deallocated, and sometimes it does while the code is running. Because I've done this before with other data types, data structures, where I would pop the element and then set some variables to the pair that's inside that queue. And I wouldn't have trouble, I wouldn't have problems. Usually it's just integers, like a pair of integers. And I set some other variables equal to that pair. Use some kind of destructuring. That must be why. That must be why. It's because I usually would destructure first and then pop. Which I think is better in general, actually. The saves on all of those like first and second calls. Let me do it that way. I think that's a much better way of doing it. Yeah, I should destructure, actually. That must be why. It's because I decided not to use destructuring, assuming that I don't need to. But actually, I should do it. Should always just do it that way. I think that's the issue. Well, I don't want to copy the string every time. That's kind of the problem. One of the problems. I think that's one of the reasons why I didn't want to do it that way. Yeah, actually it's better if I don't do it that way. I think that's why I did it. I think typically I would do it this way. Yeah, okay. I guess I copy the string here anyway. Well, okay. I'm gonna go back to what I had before. The unique pointer. Gee. Gee. That's confusing. That is confusing. Wow. Oh, boy. Wow. No kidding. Might be faster with the regular map because I don't need to allocate memory. I'm gonna try again. See how this goes. Got it. And it's slow. Quite slow. Not the fastest solution. It took me a really long time to get this too. Yeah, it's pretty slow. What if I used, like I'd used before, just a regular map? think that might be even slower. Yeah. And then what if I tried to use a regular map with not using a unique pointer. So this is technically an incomplete type, and for some reason the compiler is okay with this, which is strange, but it is. Excuse me. It could also be this that's taking a long time. This might also be slowing things down a bit. I don't know. I don't think so, actually. Whoops. Okay, let's try again. All right. Okay, it works. Still slow. About as fast as the other one. Okay. Slow answer, man. Slow answer, man. I don't know what to say. Gee. Okay. Go back to what I had before. This is basically a try. You know what? Why don't I try this? The slight optimization doesn't do as much work. Still uses a lot of memory and time. This is basically using a try to solve this question. That's kind of what this comes down to. It's a little faster, less memory. Try one more time. Can't believe I got this wrong before. Oh, I can believe it. Actually, I shouldn't say I can't believe it. It was bad that I got this wrong before. I don't know. You see here, these strings are relatively small. Hundred squared is 10,000. 10,000 by 40,000 would be too much. Never mind. trying to think if there's a better way to do this. I'm sure there's a better way. Maybe I should just read the solutions. That was pretty involved, quite frankly. A lot of details went over there. Why? What's a better answer? How am I doing on time? Hour and a half? Okay. Hmm. Maybe this is slow. I don't think so. This is kind of slow. Using an unordered map is kind of slow. Also. I'm tempted to put these substrings into a map. Make an unordered map of booleans. Maybe I can use a disjoint set data structure. Oh, I can. Oh. I can, because the folder names are unique. I can assign each. Well, the directories are not necessarily. Yeah, oh yes. No. No. No, I don't know. This solution handles those cases where it just says that the folder name is unique. It doesn't say that that each individual name is unique. Oh. In other words, you can get A, B, and you can also get /A/B, and you can also get just /A and /B. That's 3 different inputs. Oh. I don't know if that was particularly well explained. Also, am I still dropping frames? No. This is what I mean. You could have this, this, and this, where this would get eliminated. But the problem is that if I tried to use like a disjoint set data structure to connect this with this, I'd run into problems because then this would be connected to that, and that would go when this one should stay. Maybe I should have just sorted everything. It's kind of a hard question to do easily or efficiently. This is a good question. This is a tough one. Maybe I should come back to this. I mean, I already solved it, but the answer I have is kind of slow. And it took me a really long time to program it too. Could have programmed it faster, I think. Also, alpha, beta, gamma. Delta, epsilon. Just don't mind me. Oh. Trying to think. Anyway. Hmm. Trying to avoid doing two passes as well. Because I can do a substring search multiple times. See if that substring is found here. Actually, here's another way of doing it. It's a lot faster to program. I have an idea. Ready for this? Should have done this the first time. Um, okay. Something like this. Yeah, this is definitely a faster program, although I don't think this is quite right. Don't like these pictures of random people. Don't remember how exactly this works. Whoa. Almost click on those links. It's the other way around. And I'm going to find position, like position 0, for instance. And actually, I think I add 1 to that. to go off the edge. Um, um, should start with 1. Something like this. Might be some mistakes. Oh. What about that? I think I'm missing some things here. Okay, let's try that again. A, B, A, B. C, D, D. What is this? What's going on there? What? A? Where did this come from? What the heck? What? Where's substring? Somewhere in here. For some reason I don't see it. Where's my substring operator? What's going on? Oh, there it is. Okay, I was gonna say somewhere around here. Position and count. Oh, I see. Okay. I think it's gonna be 0 to I plus 1. Yeah, I was gonna say the substring. It gets confusing sometimes where what indices I'm supposed to end up with. Also, this is really taking a while, huh? Oh, I see. Okay. Um, What is going on? What? What is happening? Why would? Oh, because I is being updated here. Oh, I see. Ah, okay. It's very confusing. Just a whole lot of blank spaces, huh? What is going on? What is going on? Um, something like this. I don't know. Not too sure. It's a little confusing. Still TLEs, but now I get A, C, 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 D, C. What is happening? Why is this happening? A, B, A, B. It just doesn't. I think. Okay. Yeah, that's confusing. All right, let's do it this way. It's one heck of a subroutine here that I'm writing. There we go. Okay, now it's of course. Not only does it terminate, but it's correct. Okay. This is like a headache. That's pretty funny. What? What? Of course. Okay, I was thinking this would be a quick way to program this, but maybe this is not that quick. Oh, all right. Yeah, that's, huh. Right, because the index I is here. So you get 0, 1, 2, 3, 4. So 4 characters. Yeah, okay. All right, that's fine. It's a little confusing. It's a little confusing, but yes, that's exactly what I wanted. All right. So now the question is that does this TLE on the harder test cases? That's the question. Maybe it does, maybe it doesn't. I don't know. See what happens. Oh, look at that. Improved. Hail victory. Hail victory. Still uses quite a bit of memory, but faster to well, maybe not faster, maybe a little faster to program, and faster to program, and better runtime than what I had before. So what I had before was a little bit more confusing. This is a little bit simpler. It's kind of a straightforward approach. A lot of if statements going on here, but basically the substring can be this could be optimized a little bit. Can be optimized a little bit. Yeah. So number of characters. Maybe this is better. Let's see what happens if I do it this way. Let's see this. Oh, it worked. No kidding. Oh, what? How did I get it right the first time? I do. I'm a super genius. Okay. Is it correct? It seems weird. I minus X characters. Why does this just seem so? I didn't even do the math on that. I was like, if you start at X, so if there's 4 characters, position X is the next character to the right of everything you've got already, and then you're gonna get I minus X. I is where the forward slash is, minus X is where the other forward slash is. The index of the other forward slash. If you just subtract those two, you just lose the second forward slash. Or you lose the first forward slash. Yeah, that's exactly correct. Wow. Wasn't expecting that to work. Thought that was gonna be a little, some kind of off by one error in there. I have to figure out which one's right, or how exactly it should work. So this is a slight optimization of what I already had. A little bit faster now. Not much. Maybe a couple milliseconds faster. Not really much faster. Oh, yeah, a little bit faster. Getting closer. I don't know what they did to get 100%, but it's definitely, oh, wait. What? Oh, okay, I was gonna say, okay. Better. An improvement. Yeah, it should be clear what I'm doing. I mean, I'm basically just dumping all the strings into an unordered set and then running through all of the prefixes of each string to see if any of the prefixes are found, then we don't add that to the result, and everything else is added to the result. So this is better on memory and time than the other result, other attempts, but it's not. It's still not the fastest. Maybe I should go read the solutions. This is another way of doing this. What do the solutions say? N plus log n, m squared, ONM, brief explanation analysis. And log n, so a constant space, easy to understand. I think I had almost linear time with a try. Just sorting and log n. Oh, maybe that. I always thought about that. That might work. Length, then only parent into hash set. I don't think you need to sort it. Do you need to sort it if you do that? Oh. I think this is wrong. I don't know. I'm not sure exactly. That's kind of confusing. Oh, okay. Method 2 is faster if you have a much larger number of things to work on. It's not actually generally faster. Or method 3, excuse me. Sort folders. Sort by length? Actually, I'm not really sure what's going on with these. I don't know. I'd have to sit and think about it for a while what these are. Kind of tired. So this is incorrect. Oh no, never mind. Oh, I see. No, it is correct. Yeah. I thought about this, but it didn't seem like it'd be very efficient to do it this way. Oh, actually, that's actually a good idea. Let me try that one. I like that one. That is actually not a bad. It's better than what I was doing here. Yeah. That's a better idea. That's a good idea. I didn't think about that. That's a lot better than this one. That's a good point. That's actually a lot better. Okay. Um, So if I search for previous, if I search the current string, I find the previous string in the current string. Excuse me. If that's equal to 0, it's not equal to 0. I can push back current. This is always guaranteed to be a root directory. A directory that doesn't have, really should be the other way around. It should be 1. Yeah, there we go. Let's do it that way. Something like this. I think this is much better if I can get this to work. ABD. Oh no. Oh yeah. Oh. No, it's not just the previous ones, any of the previous ones. Oops. um, okay. Maybe this is what I'm after. Something more like this. This is what they meant. Close. So if this position is not equal to 0, or the position is 0 and position is less than current dot size, position plus 1, and current of this is let's do it this way. It's a little bit easier. It's not equal to this forward slash. Which is a little bit confusing, I realize, but this is what I think will handle this part. So AB, we get position is 0. Position is 0. And position plus previous size, 0. This size is 2, 0, 1, 2. Less than the current size, which it is, 0, 1, 2, 3. And this position, current, that spot, not equal to that. So this should be false. What did I get? Okay. Okay. Zero, 1, 2. What? What? Matches. Okay. Okay. True? Oh, that's my mistake. I got confused. Okay. No. Oh. This is so confusing. Oh, jeez. Oh, excuse me. What? If position is 0, it's 0. I don't need this. Not necessarily this is the case, by the way. Well, they could be equal in size. What is going on? If the position is, if it's 0, that means that I found previous is a substring of current starting at position 0. If it's not 0, I can push back immediately. If it is 0, then it has to be the case that in order to push back, the immediate next value needs to be a, oh, it's a forward slash. Oh, that's why. That's why I'm struggling with this. Okay. Gee, oh my goodness. I'm getting really confused too. If it has to be not equal in order to. There we go. Do I need to check that? They're going to be unique, right? It's not going to be the same thing. So if they have the same size and the position is 0, that means that I don't need to check this. Yeah. Oh. Yeah, I don't need to check that part because they're guaranteed to be not the same size, not the same strings. Okay. Let's try this. I don't know if this is going to work. This might not work. This is very wonky. Oh, it worked. Okay, there we go. That's so much faster. Oh, I don't know, man. I mean, I don't know what to say. This could also just be. This is a lot easier. This is a lot easier. Definitely much faster. Maybe not easy. It's way faster and much cleaner code. Basically does an extra substring check at each point, which is linear in the two elements. So it's pretty much n log n time. Basically n log n. The comparisons, I think, give an extra m, like nm log n, something like that. But this is really fast. I think the try solution is technically faster asymptotically, but this is still really fast. Yeah. And I think technically you could do a radix sort to make the sort even faster. Yeah. I think it's still logarithmic though. As the logarithmic doesn't make it faster, never mind. Never mind. I forgot the analysis there. This is good. I should have thought of this, actually. I was having a hard time doing it this way. I should have done it this way. Should have realized that it works. Yeah, better than 99% of solutions. Almost 100%. I don't know. How much time I spent on this? I feel like I've been at this for like 4 hours. Speeds that I came up with. Yeah, I thought about something like this, but it didn't occur to me that actually you could make this pretty efficient. Didn't realize. Yeah, dawned on me a little bit too late. Oh, I guess you could just look at the back of the result. And you don't need to do it this way. It's empty, just skip the first one. Oh, starts with. That's basically what I did over here. Although I used different routines. That would have been good, actually. Pretty sure I could have used starts with. Ooh. Ouch. Although I don't like to use the newer stuff, because it's very likely that if you're writing things in C++, you have an older compiler, and you gotta kind of learn how to do things with the older compilers. Yeah, I didn't think about that. I could have done well, adding extra characters is kind of awkward. I don't really like that. Actually, I think the way I did it's pretty good. And then, yeah, I mean, that's basically, it's basically the same code. I like this a lot. 2, 1, it's a very similar thing. nm log n plus nm squared. This is definitely less efficient. Well, depends. Actually, log n. Well, this one, I think this is actually nm log n. So this is, I'm pretty sure this is slower than, because you have the sort is nm log n. Yes, the second approach is more efficient, right? And then you can use a try. And just comparing the first two methods. This one's more efficient. This is an incorrect comparison because this comes from the sort, and he sorted in the first one as well. Oh no, excuse me, never mind. Never mind. Okay, take it back. Never mind, I was wrong. Okay. Yeah, I was wrong. I didn't realize he sorted by length first and then did the other things. Never mind. The last solution is actually linear, m by n. Yeah, this is optimal asymptotically. Although this is, even though this is asymptotically optimal, this is, what do you call that? Not going to be as fast because of just the machinery to program this, in this. There's just a lot of overhead. What do they call that? The hidden constants for most use cases are just going to be a lot larger. Like you saw that it was like twice as fast, took twice as long, just about. Took a lot longer to code, and the actual running time was a lot longer than this one. This is a very simple, very straightforward solution. I like this a lot. It's fast and quick to program. But yeah, you can see, my first solutions were like, it took twice as long, which means you'd have to have quite a few orders of magnitude in order to get a logarithmic factor to be twice as large. You need to like if your logarithmic factor was like 3 after 1,000, you need to go to 1,000,000 to get it to go up another 3 to double. Yeah, that's a lot. To get a logarithmic constant to double, a logarithmic factor to double, you have to increase by many orders of magnitude. So, yeah. Even though it's asymptotically faster, you'd have to go for quite a while. You'd have to have like very large test cases for it to matter. So I think this is the best. It's very, relatively speaking, pretty easy to program. Kind of easy to understand. Not the way that I programmed it, it's maybe not the best in terms of like understanding what I programmed. But okay, took the time to figure out a better solution here. So okay, all right. Thank you for watching. If you like the video, give it a like. Subscribe for more. Fortunately, I had some frame drops, and I kind of really struggled on this one. I really sat and thought about it for a while. I think this is okay. Got to look at some of the other solutions. Starts with it may have been better to use starts with, but there's like a few considerations there. Like I think I did okay with this one. And what else do I want to say? Yeah, thank you for watching. I mean, that was kind of a challenging question. That was a good one. That was a good question. I had to really think about it. I mean, I did get the try solution pretty quickly, but like, it's not like a good solution, quite frankly. It was not really the best for various reasons. And it was good to kind of stretch my mind a little bit regarding like, I don't know, incomplete types in C++ and using shared pointers and misusing a queue, and there were like a lot of different things I went through there. And then yeah, I got to practice tries and level order traversal and a level order traversal with the optimization that I had in there too. There was a slight optimization that was good. Yeah, there's a lot we went over there. There's a lot of different things, details. That's pretty good. That was good. All right, I'm gonna go. Thank you for